Hello. Now, today we are going to be talking about hypothesis testing for the sample mean. So we already did hypothesis testing for our population proportions. This is going to follow very similar steps. We're going to look at a confidence interval, and we're going to test whether our particular example is inside or outside of that 95% confidence interval. Now, for reasons that I don't have any argument for, the course requires you or encourages you to structure the hypothesis test for a sample mean a little bit differently. In that, you will remember that 95% of our standard normal distribution lies between our z-scores, remember our z-scores, between plus or minus 1.96 away from our mean of 0 on our standard normal tables. These are the z-scores that give us our probabilities on our log tables on page 36 and 37. So the way that the hypothesis test for a mean is, or for a sample mean, is set up is that we're going to get the z-score for our particular situation and see whether it is inside or outside of this plus or minus 1.96 standard deviations away from the mean on our standard normal table. That doesn't make sense? Don't worry, we're about to do an example. So to do the example, we're looking at page 344, because I'm not very good at coming up with our English language questions. Question 2. Over a long period, the scores obtained in a particular intelligence test were normally distributed with a mean score of 70 and a standard deviation of 6. When a test is taken by a random sample of 64 students, the mean score is 68. Is there sufficient evidence at the 5% level of significance that these students are different from the normal students? Now, what does at the 5% level of significance mean? Well, we're dealing with a 95% confidence interval, so there is 5% outside of our 95% confidence interval. So if you add up the area underneath here and the area underneath here and the tails, it adds up to 5%. So at the 5% level of significance, means we're dealing with our 95% confidence interval. You don't need to really worry about that language. From your point of view, it doesn't mean anything because there's only one level of significance you're required to know for the Leaving Cert. So don't worry really about the 5% level of statistic of significance. You will recognize this style of question from the other information that they give you. If they talk about means and standard deviations and sample sizes, this is the type of question you're going to be dealing with. And it will specifically ask you to test in these type of questions. So, what are we always going to do first? We are going to write down the information that is given to us. So we are told that we have a population mean, mu, of 70 and a standard deviation of our population of 6. We're told that we have a sample mean, we're told that we have a sample size, I should say, of 64, and we're told that we have a sample mean, which we call x bar, of 68. We have two different means going on here. We have the mean of the population that's given to us. This is the established mean of a population. This is the mean of our sample. So the population mean is mu, the sample mean is x bar. And sigma by itself means the population mean. Now, this population standard deviation, sorry. Now, the key point here is n is larger than 30. So because n is larger than 30, we're able to assume that we are dealing with a normal distribution. You're not required to mention that in the question, but they could structure an exam question where they asked you what would be the smallest group that you could make these assumptions with, and you're supposed to know that it's 30. So that's why I'm mentioning it all the time. Now, let's get into it. We're going to follow steps just like we did for the population proportion. for the sample proportion hypothesis test, we're going to follow exactly the same style of thing. So what was first in them? Well, in part 1 we set up our null hypothesis and alternative hypothesis. So what is our null hypothesis in this particular case? I'm going to say it's the mean of this population is 70. So our mean is going to be 70 is what I'm going to assume going in. And what's the alternative? Remember, you can also see that written as H1. The alternative hypothesis would simply be the antithesis of that, the opposite of that, which is going to be that the mean is not 70. That's our step 1. So remember, you're following steps like you're doing a proof. Step 2, we are going to get what's called our test statistic. Now, it has a different name for reasons, very little reason. It's just the Z-score that you're already familiar with. So we're going to get our test statistic. I'm going to use that word because they could use it in the exam. Test statistic. Sorry, that's a T. Test statistic. Z-score. So we're going to find the Z-score of this situation. So we have enough information to go into our Z-score formula. This formula that I'm writing here is on page 35 in your log table, so you don't need to know this one by heart. And it's under the hypothesis testing title on page 36, top of page 36. No, 35, my apologies. Top of page 35, if I remember correctly. Now, we have enough information to go into that formula, so we are going to sub in. I've written it all out here, and I've written my formula down, so now I can sub in directly. 70 all over 6 all over square root of, and they give us a nice number this time, they give us 64. When you put all of that into your calculator, you will get minus 2.6667. It's just 6 recurring. So we have a Z-score here, and our Z-scores really only work to 2 decimal places, so I am going to approximate it to minus 2.67. Now, that's our Z-score. If I go back up to my table here, what I want is to see that my Z-score is in between 1.96 and minus 1.96. Well, Z is minus 2.67 is somewhere all the way down here. So that is not inside of our 95% confidence interval. So the 95% confidence interval for this type of question is going to be written as, is going to be a standard form, effectively. So our 95% confidence interval is going to be Z, your Z-score must be between plus or minus 1.96. So in this particular case, your confidence interval is always the same. You're checking whether the Z-score that you get is within the 95% confidence interval that you would get from the standard normal table. So you are looking for whether this result is inside the range plus 1.96 down to minus 1.96. And we can see from the picture and also just from the numbers that our Z this time is outside of that range. So step 4 is going to be to state that. It is very important to keep in mind this is part of the question. This isn't an extra bit. The final block of marks for this question is for stage 4, your conclusion. You must give your statement of what you have discovered. And in this case, as Z is equal to minus 2.67 is outside of the 95% confidence interval. We reject H0, the idea that the mean of this new sample could be 70, and we accept the alternative hypothesis. Now, that's all you need to write down. What this means is there is reason to say that this group of students is different. Think these students, to think these students are different. Okay, so that is our steps for doing a hypothesis test for a mean. Now again, there are quite a few steps in these questions, but they're always the same. You're going to be given enough information to set out your null hypothesis, your alternative hypothesis. You're going to get your test statistic, which is just your z-score, and it's on page 35 in your log tables. You're going to check whether it is between plus or minus 1.96. If it's outside of that range, you're going to reject your null hypothesis. And if it's inside the range, if it was, if you got a z-score of, say, 0.5, then that would be inside your confidence interval, and you would accept the null hypothesis that nothing needs to change. And that is what you are looking for with your hypothesis test for your sample mean. So again, lots of different steps in it, but because the steps are always the same, it's a fairly good question to practice because it's so repetitive. And that's what we need for right now.